Picture a winter that never seems to end. No animals in sight, ground frozen solid, children crying from hunger. This was not an unusual catastrophe for ancient humans. It was just another year. For roughly 300,000 years before the first farms appeared, every human who ever lived faced the same problem. Food ran out regularly, predictably, mercilessly, and yet somehow every one of your ancestors survived long enough to have children. How? The first answer is inside your body right now, whether you've eaten today or not. When food disappears, the body doesn't shut down. It switches fuel sources. For the first 24 hours without food, your liver burns through its glycogen stores, roughly 2,000 calories worth of glucose. After that, fat cells begin releasing fatty acids into the bloodstream. The liver converts them into ketone bodies. The brain, which normally runs on glucose, learns to run on ketones instead. This metabolic switch, called ketosis, was not a malfunction. It was a design feature. A healthy adult human can survive without food for 30 to 70 days, depending on their fat reserves. Some documented fasting cases from the 20th century exceeded 382 days under medical supervision. Ancient humans were not medically supervised, but their bodies ran the same program. Once fat runs out, the body makes a harder trade. It begins consuming muscle protein for fuel. This is the phase where starvation becomes dangerous, but it also bought days, sometimes weeks, of continued function. The body was not surrendering. It was rationing. But biology alone could not save a group of people through a season-long famine. That took strategy. Hunter-gatherers almost never depended on one food source. Researchers studying the Khoisan of southern Africa found they regularly identified over 100 plant species as edible. When the hunt failed, they gathered tubers. When tubers were buried under frost, they cracked open termite mounds for insects. When rivers dropped, they waded into mud flats for mollusks. This wasn't desperation. It was a deliberately maintained knowledge base held across the whole group. One of the most calorie-dense foods available to prehistoric people was hidden inside something most hunters threw away: bone marrow. A single femur from a large deer can contain 400 to 500 calories of dense fat even when the meat is gone. Archaeologists have found deliberately fractured animal bones at sites in Kenya dating back 1.45 million years. This was not accident. These bones were cracked open on purpose, using stone hammers to get to the fat inside. The brain, liver, heart, kidneys, organs that many modern people discard were the parts ancient hunters fought over. Gram for gram, liver contains more vitamin A, iron, and B12 than almost any other food. In a starving group, that mattered. But perhaps the most powerful survival tool was not a food at all. It was the practice of sharing meat after a successful hunt. Anthropologist Kim Hill spent decades studying the Ache people of Paraguay. He found that successful hunters shared roughly 80% of what they killed with other families. An individual who kept everything had an advantage today. A group that shared everything had an advantage every day, because the hunter who returns with a kill today may return empty-handed for the next 2 weeks. Sharing converted individual luck into collective insurance. Over thousands of generations, this became embedded in human social instinct. The impulse to feed a hungry person next to you is ancient. It is older than agriculture. When food sources in one area collapsed entirely, groups moved. This was not wandering. Paleoanthropologists studying movement patterns of early Homo sapiens found consistent seasonal migration routes tied to animal herds and fruiting cycles. Groups in southern Africa followed wildebeest migrations covering over 500 miles annually. The people who stayed put during a famine often died. The people who moved often found food. Within a moving group, the people who kept everyone alive were not always the strongest. Older women were among the most critical survival resources a group could have. Anthropologist Kristen Hawkes, studying Hadza foragers in Tanzania in the 1980s, documented what she called the grandmother hypothesis. Grandmothers who were past reproductive age spent more time foraging than any other group member. They fed grandchildren while mothers nursed infants. Their knowledge of where food hid during droughts, which roots stayed edible under snow, where the water sources were in summer, that knowledge was the difference between life and death. A tribe that lost its oldest members lost its memory. And without memory of where food was, the group starved faster. Children faced the opposite problem, not a lack of knowledge, but a lack of reserve. A child's fat stores can be depleted within days of food restriction. That is why mothers continued breastfeeding even when they themselves were undernourished. The body prioritizes milk production even at significant cost to the mother's own tissue. This is not a choice. It is physiology. There is one topic in the archaeology of starvation that most popular accounts skip past quickly: the evidence of cannibalism. At Gough's Cave in Somerset, England, archaeologists found human bones dating to around 14,700 years ago with cut marks identical to those on butchered deer. The skulls had been shaped into bowls. The long bones were cracked for marrow. Whether this was survival cannibalism or ritual, researchers still debate. What the cut marks confirm is that the bodies were processed with the same precision used on animals. These cases were rare in the fossil record. They appear at moments of acute, documented environmental collapse, not as regular practice. They tell us something about the absolute edge of human survival, the point at which every other option had already failed. Now consider the full picture. Ice ages that locked the northern hemisphere in ice for 10,000-year stretches. Mega-droughts that dried out entire continents. Volcanic winters that blocked sunlight for years, like the Toba eruption 74,000 years ago, which geneticists believe reduced the entire human population to perhaps 10,000 individuals, 10,000 people, the population of a small town today. That was all of us, and we survived anyway, through ketosis and marrow, through migration and memory, through sharing meat with strangers and following herds across continents. The Toba survivors left Africa and spread across the planet within the next 30,000 years. Every human alive today descends from that remnant group. When you skip lunch and feel irritable by 3 p.m., your body is running the same metabolic code that kept a woman alive in a frozen cave 40,000 years ago. The hunger you feel is uncomfortable. For your ancestors, it was a constant companion they learned to outthink, outshare, and outlast. That is the actual story of human survival. Not strength, not speed, a body that rationed itself, a mind that remembered where food was, and a group that refused to let any one person starve alone.